Alright guys, today is going to start out our Unit 2 officially. So in the end of Unit 1, we were introduced to 1 and 2 step equations. In Unit 2, we're going to go ahead and pick up where we left off with our equations. And so today's lesson is going to be about what do you do when there's a variable term multiple places. So it could be on the same side or it could be on opposite sides, but there's more than one variable term. If you look at both examples, I can see multiple variable terms, so I've circled them. All right, let's talk about what we do when those multiple variable terms are on the same side of the equal sign, okay? What you're going to hear me say repeatedly is if they are on the same side, then we're going to use or keep the same sign. So keep same sign. Okay? And when we keep the same sign, what we end up doing is just combining like terms. And the abbreviation for that is CLT, combine like terms. Once we combine these like terms, make sure that you keep the sign in front of them. Whatever it is, that's what we do with them. So I have a positive 2x and a positive 8x. I'm going to combine them to get a positive 10x. And then I bring down everything else in the equation. So this minus 9 comes down, equals, and the 11 comes down. And now I have a simple two-step equation to solve, just like we were doing at the end of Unit 1. So let's add 9 to both sides, draw our line. 11 plus 9 is 20. Bring down the 10x. And then to break up the variable term from the coefficient, we divide by the coefficient. So my final answer is x equals 20 divided by 10 is 2. Oh, I'm trying to circle it. There it goes. So that is a variable term when there's more than one on the exact same side. What I'd like for you to do is look at the bottom part of your paper underneath this, and I want you to practice these 4 that are on the same side. Practice ones, okay? That's only the left side of the paper. So 1, 2, 3, and 4. Pause the video and go ahead and practice those 4 problems. So I've completed example number 1 almost all the way through, but most students probably got to this point and got really confused. Our 4s did cancel out on both sides of our equal sign. So what we end up needing to do when one side of the equal sign has nothing on it, we need to leave a 0 there for a placeholder, all right? And so once you've put that 0 there for your placeholder, then we can do our last step, which is to divide by -2. And 0 divided by anything is just going to be 0. And that's our answer. Go ahead and try number 2. If you're feeling pretty comfortable after example 2, go ahead and complete 3 and 4 on your own. If you're still kind of struggling after example 2, I'd like for you to call Miss Brown over and start working out number 3 with her there to kind of guide you. All right? So if you're going to work on 3 and 4, go ahead and pause the video. Or if you're going to call Miss Brown over, go ahead and pause the video. Hopefully by now, everyone has been able to successfully complete numbers 3 and 4. And I just want to say about number 4 is that many students are probably very bothered by the fact that the answer is a fraction. I just want to let you know that fractions are numbers too. We don't want to discriminate against our fractions just because they do make a lot of us uncomfortable, but they are still in our real number system. They are still rational numbers, and sometimes our equations will have an answer that is a rational number, and that's okay. All right, let's go ahead and continue our video with what to do when there are variable terms that are on opposite sides. So, if I have variable terms on opposite sides, I'm going to need to use the opposite sign. Okay, so I'm going to add this to my notes. That should say opposite. That doesn't really... Okay, so on the opposite side. What that means is that when we're solving, we will need to use inverse operations. All right, so let's look at this example down below. You can see that I've already done step 1, which is to draw the rose line, and I've already completed step 2, which is to circle the variable terms. It is important to me that while we're learning and practicing right now, that we are completing those first 2 steps, all right? For most of you, especially those who are very visual, this will help you to see that those circles are on opposite sides of the rose line. So we should know now in step 3 that we need to use the opposite sign to combine them, all right? So we're going to pick just one of them. I'm going to go ahead and move the 3 over. Currently, that 3x is a positive 3x. So I will subtract the 3x. Use the opposite sign. Okay, 3x minus 3x is going to cancel. Bring down the 7. Bring down the plus 2. And now we're going to combine these. 2x minus 3x is negative 1x. Once you've done that step, now you can see that we're right back to a normal 2-step equation again, just like we were with the same side example. So I am going to move the 2 over. That is my constant term. And then I will do the inverse operation of multiplying by negative 1, divide by negative 1, and my final answer is x equals negative 5. All right, step 1, draw my rose line. Step 2, circle my terms. They're on opposite sides. So step 3 is move one of them over to the other side. So I'm going to add this 4x to both sides. (2x plus 4x is 6x. Okay. Then I'm out of room to show my work, but let me add 4 to both sides. Negative 4 and positive 4 will leave me with 6x, let me write it over here. It's going to leave me with 6x equals 0. And then 0 divided by 6 will be 0. All right. Let's do number 2 together. Okay, step 1 is to draw the rose line. I'm sorry, this is example 6, but it's the second one of this kind. Circle my variable terms. Okay, I'm going to move over the 4. I don't know if you notice, but I tend to just always move it to the left. All right, and then let's move over our 7. So subtract 7 from both sides. That will give me negative 25. And bring down the negative 12x. My very last step here is going to be to divide everything by negative 12. Divide by negative 12. Okay. Negative 12 divided by negative 12 cancels, leaving me with x. Negative 25 divided by negative 12 is negative and negative makes it become positive. And so the answer is just 25 over 12. This doesn't reduce. I don't have to change it to a mixed number or a decimal. I can just leave it just how it is. And I'm done. If you're still having some questions, or if you're not quite sure that you've got it down yet, go ahead, pause the video, try number 7. If you're struggling, call Miss Brown over. If you do number 7 really well, move on to number 8, and then just pause the video while you're working, okay? All right, hopefully everybody is doing okay with having more than one variable term in an equation. Let's go ahead and add the last part of today's lesson, which is how to handle, oh, and let me say that there is, never mind, I'll get there in just a minute. Okay, with parentheses, you must distribute to eliminate your parentheses. So distributive property is what we're going to use here. So I'm going to go through my 4 steps out to the side, starting with 1, which is draw my rose line. Step 2, distribute the 4 into everything in there to eliminate my parentheses. Okay, step 3 is to start out with your 2-step equation step, which is doing the inverse operation, of the constant term. Negative 12 minus 12 is negative 24. Bring down the 8x. Okay, the inverse operation of 8 times x. This is my last step. Divide by the 8. So x equals negative 3. And I'm finished. You might even have found this one to be a lot easier than having more than one variable term. Okay? Hopefully everyone feels pretty comfortable with that one. So I want you to look down at the 4 practice examples below. And I'd like for you to do numbers 1 and 2 here first. So you're going to pause the video, do numbers 1 and 2, and then come back and check your work. And if you're feeling pretty good, then we're going to do example 3 together and 4 and talk about how to get rid of these fractions. All right? So go ahead and pause your video. All right, so those are examples or practice problems 1 and 2 with the distributive property. Let's take a look at practice number 3. Okay, so what makes this different is this 2 that's in the bottom. The easiest way to get rid of fractions is to multiply everything on both sides of the equation by what that denominator is. So even if there was a number in the top, I would only try to multiply by the denominator. I would ignore the top number, okay? So I'm going to multiply all that by 2 and all that on that side by 2. That will cancel, and this 3 times 2 will become 6. And so I'm left with this x plus 4, bring down the equals, and then the 6 is over there. And that's it. That's all I did was multiply everything by the denominator, the 2. Now I have just an easy one-step equation. Subtract 4, and x equals 2. Okay, let's do one more just like that. So draw my rose line. I don't want to do distributive property yet. I want to eliminate the fraction if I can, okay? Can you distribute? Sure, but I think it's easiest to just eliminate the fraction. Okay, so my denominator is a 3, so I'm going to multiply this by 3 and this by 3. Now I have 24 equals, those cancel out, 6x minus 9, and now I have a 2-step equation. Let's add 9 to both sides. Okay, so 24 plus 9 is 33. I'm going to divide both sides by 6. And x equals, let's see, how many times does 6 go into 33? I know 6 goes into 30 5 times, which means that there's 3 left over. So 3 over 6 reduces to 1/2. You could have also just reduced 33 over 6, dividing both by 3, and that would have given you 11 over 2. Okay, either way. So when it comes to distributive property in parentheses, if there's a fraction in the front, I would recommend that you just eliminate the fraction, okay? Actually, I do need to. I'm going to add one more example, and you can put this at the bottom of your paper, okay? I want to do an example that has a fraction that does not have a 1 on top, all right? And I'm just making something up here. 2x plus 1 equals, let's say, 10. Okay, so I'm going to draw my rose line. I told you the easiest thing to do would be to multiply both sides by the denominator. So there we go. Those cancel. I now have 10 times 3, which is 30 over here. Bring down the 2x plus 1. And here is why I did this example. I wanted to point this out. You still have a 2 in the front of the parentheses here. So because that 2 is still there, you want to keep the parentheses around it. And you will still need to do your distributive property. So now I can distribute 2 times 2x is 4x. 2 times 1 is 2. And bring down your equal 30. Now I'm going to subtract 2. 4x equals 28. Divide by 4. And so x will equal 7. All right? So that was the only thing that was different. If you have a fraction that has a number on the top, you have to still bring that down and do the distributing part of our steps, all right? Okay, now there is a section at the bottom of your paper that says put it all together, and it has examples 5, 6, 7, and 8 underneath these 4 practice ones. I do not want you to complete those yet. We will do those with a part or as a part of tomorrow's lesson. All right? So for now, go ahead and get your homework started on quizzes or whatever Miss Brown posted to Google Classroom. And you may get started on that, or you may raise your hand and ask for any help, get any questions clarified that you still have.